Okay, I'm going to run through these notes pretty quickly. So this is covering differentiation and differentiability. So the first thing is, we talked about this in class a little bit, is the limit definition of the derivative. So 1 through 4 are all set up in that definition. So what you have to do is figure out what the function is that you're taking the derivative of. So the definition of the derivative is the limit as h approaches 0 of your function of x plus h minus the function all divided by h. So you first just want to figure out what your function is. So your function here is sine x, not negative sine x, it is sine x. So our function is sine x, and then what this whole long thing limit means is you want to find the derivative of that sine x. So then f prime is just equal to the derivative of sine, which is cosine. Okay, so then number 2 should be really easy. Our function is x to the 7th, so then this limit would be equal to the derivative of x to the 7th, which, applying power rule, you get 7x to the 6th. Okay, for number 3, again, here's your function, 1 over x to the 6th, so we want to take the derivative of that. So 1 over x to the 6th, I would write that in the exponential form, which would be x to the negative 6th. So then when you take the derivative of this, you would get negative 6x to the negative 7th. Or you could write negative 6 over x to the 7th. Okay, the next one, 1 over the square root of x, is our function. And again, I'm going to rewrite that in its exponential form. So that's going to be x to the negative 1/2. And so when I take the derivative, that's negative 1/2 x to the negative 3/2. And I'm just going to leave it like that. Okay? All right, so the next thing is write the equation of a tangent line. Okay, when you're writing an equation of a tangent line, you need 2 things. You're writing an equation of a line, so think algebra here. And we're going to use the formula y minus y1 equals m times x minus x1. So what do you need for this? This is point-slope form, so we need a point and we need a slope. All right, our point, what that's going to be is our function evaluated at the x value that they give me. So our x value is 1, so I want to find f of 1, and that'll be the y value of the point. And then the slope is going to be the derivative evaluated at our x value, which is f prime of 1. So I'm going to first evaluate f of 1. So f of 1, if I plug in 1 here, that'd be 3 plus 1 is 4 minus 2 is 2. And then we need to find f prime of 1. So first I'm going to evaluate or find f prime. So that, applying power rule, the derivative of 3x squared is 6x. Plus 1. Then I need to find f prime of 1. So that will be 6 plus 1, which is 7. Now you're not finished yet. You have to write the equation now, y minus y1. So the equation is going to be y minus y1 is 2. And that equals 7 times x minus x1, which is 1. You don't need to simplify. Leave it like this. Okay? All right, so then the next question asks for the equation of the normal line. So the normal line, you're going to do the exact same steps as the tangent line, except for the normal line is going to be the perpendicular line. So when you find the slope, all you have to do is take the opposite reciprocal, and that's your slope. So we're going to do the same thing. We want a point, and we want a slope. Okay, so our point, we have 3, and then whatever the y value is at 3, so f of 3. And then our slope is f prime of 3. Okay, and actually that's the reciprocal, the perpendicular slope to that, the opposite reciprocal. Okay, so let's find f prime. So 3 times 1/3 is 1, and that'll be x squared minus 2x. So then f prime at 3, oh, sorry for my notation there, f prime at 3 is 3 squared minus 2 times 3, so that's 9 minus 6 is 3, and we also want to know our point, so f of 3 is equal to 1/3 times 3 cubed, oh, what is 3 cubed? 27, divided by 3 is 9, minus 9, nope, 9 minus 6, nope, 9 minus 9 plus 1. Sorry, I'm butchering this. Hold on. Okay, brain fart there. Yes, it is 1. So our point is 3, 1, and our slope is 3. But again, we want the normal line, so our slope is going to be the opposite reciprocal, so that's going to be a negative 1/3. All right, so now for our equation, we're going to say y minus y1, so that's y minus 1 equals, our slope is negative 1/3, x minus our x value of 3, and that's our answer. Okay, the next problem is looking for what values of x does the graph of x cubed minus 6x squared plus 9x minus 2 have horizontal tangents. So we're not looking for the equation of the tangent line, but we know that the tangent line is horizontal. Therefore, we know that the slope for f prime is 0 for a horizontal tangent line. So the first thing we want to do is find y prime. So that's going to be 3x squared minus 12x plus 9. And then if we want to find when the slope is equal to 0, the slope is represented by the derivative. So we want to know when the derivative is equal to 0. So we set this equal to 0, and now it just becomes a quadratic that we have to factor. So we're going to factor out a 3 first to get x squared minus 4x plus 3. And then we want to factor that. So that's going to be x minus 3, x minus 1, I believe, yes, equals 0. And then at what values of x? So they want to know two x values. So that would be 3 and 1. So at the x values 1 and 3, this graph would have horizontal tangents. Okay, so the next one, part number 8, same question, but this time we have a quadratic with no numbers. We have the variables a, b, and c. So it's going to be in terms of a, b, and c. So we're going to do the same thing for horizontal tangents. We're going to take y prime, so that would be 2ax plus b. And so if I set that equal to 0, you would get that x would equal negative b over 2a, and that should ring a bell as being the line of symmetry for a quadratic. Okay, next we're looking at the rules, the quotient rule and product rule. So again, I went over those rules in class, so I'm not going to write those down, but we're going to apply them here. So in number 9, that's a quotient, so we're going to use the quotient rule. So the quotient rule is low d high, so the low function's x times the derivative of sine is cosine, minus high d low, so the high function sine times the derivative of x is 1, all divided by low low. Simplify if you can. This one does not simplify, so you're done. Number 10. Number 10 is a product rule of x squared times cosine x. So product rule says take the derivative of the first function times the second function plus the first function times the derivative of the second function. Derivative of cosine is negative sine. So I'm actually going to go back, and if you thought about it beforehand, you could put a, oh, that's not the eraser. There you go. If you thought about it beforehand, you could see cosine, derivative of cosine is negative sine, so that's going to be a minus x squared sine x. Doesn't simplify, leave it alone. All right, number 11, quotient rule. Low is 3x minus 2. Low d high times derivative of high is 2x minus high d low, all divided by low low. Okay, I'm going to leave it alone. Y'all can simplify, but that's the rule for the derivative. And the last one is quotient rule again. So low d high, derivative of the high is 1, minus high d low, all over low low. Again, for sake of time, I'm going to leave it alone. Okay, looking at numbers 13 through 16, we have a position function for a particle that's moving along the x-axis. So just imagine there's just this dot that's moving along the x-axis right and left. And x is measured in kilometers and t is measured in hours. So we want to find the particle's velocity at time 0 using correct units. So imagine it's moving, and we start a stopwatch, and it's already moving. So we want to know what the particle's velocity is at that initial time. So hopefully you've learned that when you have a position function, that the velocity function is the derivative of the position function. So remember, a derivative is a rate of change, and velocity is the rate of change of your position. So all we have to do is take the derivative of the position function, which would be 3t squared minus 12t plus 9. And we want to know what the velocity is at time 0, so all we have to do is plug in 0 for each t, and we'll end up with 9. Correct units, so our velocity is 9, kilometers per hour. Okay? Then it says, when is the particle at rest? So when I'm at rest, that means my velocity is equal to 0. So now instead of putting 0 in for t, we're going to set our function equal to 0. And factor. And we're left with t minus 3, t minus 1, same as earlier. So the particle is at rest 2 times at 1 hour and 3 hour time period. Okay, next is, when is the particle moving to the left? Since this particle is only moving along the x-axis, it's only moving left and right. So if it's moving to the left, that means its velocity is negative. So our velocity is less than 0. So we want to know when the velocity is less than 0. Well, we already know when the velocity is equal to 0. So what you want to do is make a sign chart here. So I know that my time is starting at 0. My time is starting at 0. So think of these as times here. So this is time 0 here. I don't go past 0. And then you have at 1 hour and at 3 hours, our velocity is 0. So this is like looking at a graph along time of velocity. So we want to know, in between the time period 0 to 1, between 1 and 3, and after 3, what is the velocity doing? So you're going to use this factored form here, and you're going to kind of just plug in values of t in each interval to see whether it's positive or negative. So between 0 and 1, I would use 1/2. So if you plugged in 1/2 over here, 1/2 minus 3 is a negative. 1/2 minus 1 is a negative. So a negative times a negative is a positive value. So between 0 and 1, the velocity is positive. Between 1 and 3, I would use the value 2. So if you plugged in 2 minus 3, that's a negative. 2 minus 1 is a positive. Negative times a positive is a negative. And then the last one is going to be positive. So using the sign chart, you can see that the particle is moving to the left, where the velocity is less than 0, and that is between time 1 and 3. Okay? The last question, find the particle's acceleration. So if velocity is the rate of change of position, or the derivative of position, then acceleration is the rate of change of velocity. Okay? Or the second derivative of position. Okay, so we want to find the particle's acceleration at t equals 0, so we need to take the derivative of velocity, this one right here. Okay, so 3t squared is 6t minus 12. We want to set that equal to 0 and solve, so that would be, we want to find the particle's acceleration at 0. So we would just plug in 0 for t, which would give us negative 12. And the units on that would be kilometers per hour squared. Okay, these next problems are covering the chain rule. So with the chain rule, you have compositions of functions, functions within functions. So you want to think of, especially square roots, as their exponential form. So I'm going to think of this as x squared plus 3x to the 1/2. So the outer function here is to the 1/2 power, so that would be power rule. So 1/2 times, leave the inside exactly the same, don't touch it, and then to the negative 1/2 power. Then that all times the inside, x squared plus 3x. Okay, I'm just going to leave that for now. I'm going to let y'all clean that up. I'm just going to do the calculus for this video. So now 18 is sine of x squared. The outside function is sine. So then the derivative of sine is cosine of, leave the inside the same, then times the derivative of x squared. Now this one I will mention about cleaning up, because you want to make sure and be careful that the 2x is not inside the argument of cosine. So I would actually prefer you write this like this, 2x times cosine of x squared. That looks a lot better, so there's no confusion. Okay, so 19, this would be 5 minus 2x to the 1/3 power, so y prime would be 1/3 times 5 minus 2x to the negative 1/3, and then, 1/3, nope, 1/3 minus 1 is negative 2/3, and then that's times negative 2. Again, clean that up. All right, and then number 20, cosine squared of x. Remember, like I said in class, this is the same as cosine x squared. So the outer function is squared. So this would be 2 times cosine x times the derivative of cosine, which is negative sign. So I'm going to put the negative out front and then the sign. Okay? All right, now this next section, I'm actually going to change up the instructions a little bit. Instead of finding for what values of x does each function have a horizontal tangent, I just want us to find the derivative. Okay, that's all we're going to do. And we are going to simplify. Okay, and then we'll talk about finding the horizontal tangents, but we're not actually going to do that. All right, so we want to find the derivative here, and this is probably going to take up a lot of space because it's got chain rule and product rule both together. So overall, this is a product rule of two things. Within those product rule, when you take the derivative of each, you will apply the chain rule. Okay, so y prime is the derivative of the first function. So that's going to be 6 times 3x minus 5 to the 5th power times 3. Don't forget, you got to multiply by the derivative of the inside. Now, this is product rule, so that's the derivative of the first times the second. So that's going to be the 2x plus 1 cubed. Then plus the first times the derivative of the second. So that would be 3 times 2x plus 1 squared times 2. Okay, so we're actually going to simplify this one together. So I'm going to kind of clean this up a little bit with my coefficients. So 6 times 3 is 18 times 3x minus 5 to the 5th power times 2x plus 1 cubed. And then here we have 3 times 2, so that's going to be a 6, and I'm going to put that 6 out front. And then I'm going to, oh, oops. Sorry, guys. Okay. All right, so what I want you to see now, and I meant to erase this parentheses here. There we go. Add that again. Okay, it's kind of cluttered on here, so I apologize for that. But what I want you to see here is to completely simplify, and really in order to find a horizontal tangent. So we're not going to do this fully, but in order to find a horizontal tangent here, I would not want you to set this equal to 0 and try to solve, but what you want to think of this is factoring out common factors. So if you look here, we've got a 3x minus 5 factor in each term, and we've got a 2x plus 1 factor in each term. And then we have 18 and 6, which also have a common factor. So you want to factor out everything in common with both. So think of this as one big, long polynomial. So 18 and 6 have 6 in common, so I'm going to take that out. Then 3x minus 5, there's 5 factors here, 6 here, so I'm going to take out 5 of them. Then the 2x plus 1, there's 3 factors here and only, oh, that should have been a 2 factors here, so we're going to take out 2x plus 1 squared. Okay, so think of that as one big factor, or greatest common factor, that I've taken out. So now what's left? 18 divided by 6 is 3. 3x minus 5 to the 5th power, gone. 2x plus 1, I took out 2 factors, so 1 is left. Plus a 3x minus 5 factor. Okay, I'm going to do one more step to clean this up, so this all stays the same. And then if you clean this up, this would be 6x plus 3 plus 3x minus 5, so 6 and 3 make 9x, and 3 minus 5 would be negative 2. So then each of these, so if I were to say where each of these has a horizontal tangent, now it's in factored form. So you would set each of these factors equal to 0. So really, we kind of did the original problem, but 3x minus 5, that would be 5/3, negative 1/2, and 2/9. So that's where the function would have a horizontal tangent. I'm not going to do, again, for sake of time, 22, so you can do that on your own if you want, but I'm not going to do it for this video. Okay, last one. We're going to do, I'm only going to do one of these. I think I'm going to do the second one. I think it's a little bit more challenging. Okay, so this problem says find the values of a and b for which each function is both differentiable, and it doesn't say continuous, but in order for a function to be differentiable, it also must be continuous. Okay, so you need to both continuous and differentiable. So what continuous means? Continuous means, especially if I have a piecewise function, these are piecewise functions. So I'm going to call this G1 and I'm going to call this G2. So what continuous means, and for 24 we're at the value 1. Okay, so continuous would mean that G1 at 1 would equal G2 at 1. That's what continuous would mean. What differentiable would mean is that G prime of 1 at 1, so the derivative of G1 at 1, would need to equal the derivative of G2 at 1. Okay? So we need to look at both of those things. And what we're going to end up having is a system of equations. So we have two equations with two unknowns, A and B. Okay, so let's first take, let's look at the continuous. So what I'm going to do is I'm going to say when G1 of 1, what is that, and what is G2 of 1? So all it means is I'm going to put 1 in for x, and I'm going to evaluate that. So I've got 12 minus b, x squared is just 1, and that equals a over 1, or just a. Let's make that look prettier. Okay, so that's one of my system of equations. But now we need another equation with a and b in order to solve. So what that means is I'm going to find g prime. So g prime, all you have to do with a piecewise function is just take the derivative of each one separately. So 12 is a constant, that's going to be 0. The derivative of negative bx squared would be negative 2bx. And the derivative of a over x, again, think of this as ax to the negative 1. So that's going to be negative ax to the negative 2. Or, what I would prefer, negative a over x squared. Alright, so we want to evaluate both of those at 1, so that's going to be negative 2b equals negative a over 1, so that's just negative a. Or in other words, 2b equals a. And so this is my other system, or other equation in the system. And now we're going to substitute. So then I get 12 minus b equals 2b. So 12 equals 3b. So b equals 4. And then a is twice that, so a is 8. And that is